Next, we want briefly to discuss how to simplify certain complex numbers that we're likely to run into. Here's an example. Again, it says write in standard form. So I look at these two and they don't have a whole lot in common at first glance. And then we think about the same principle that we used to factor out the negative 1 in the first place for the square root of a negative number. The common factor that we see in both of these, well, we have one bigger than negative 1. We could take a negative 2 out of both of those. So we do. And this conveniently gives us two perfect squares under the other square roots. I'll take them. And in this slide I have factored out the negative 1 also. So on the left I have 10 times I times the square root of 2 and 9 times I times the square root of 2, which combine to give me a complex number with only an imaginary component. This one has no real component. Now notice in this case I embedded the I in the middle of that number, and the reason for that is that if I put the I at the end after the square root of 2, well, maybe you would believe how often that I seems to get confused with the 2 itself, so that it looks like square root of I. To remove all doubt, we will say I times the square root of 2. Here's another one. This one looks very much like something that we might get as a result of using the quadratic formula. The only difference is it doesn't have plus or minus here. At any rate, on we go. So we break it into real and imaginary components, and now we got to simplify what's left. On the left we get that negative 3/8. On the right I again break up a complex number into factors that work as well as possible, if not all that well, with the square root. So this is my result. Make sure that you can produce that result too, of course.